Developers now have a big target on their back where they are now under direct assault by the hackers who used to just go in the front door, attack servers, do all sorts of more obvious exploits. Now they're doing very clever backdoor exploits.
This is DevOps Paradox, episode number 206, Open Source Supply Chain Security with Pyrsia. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsa. Victor, here we are. We're in April of 2023, and conference season is starting up. And one of the top things I think we're going to see this year is supply chain security and everything around that. What do you think?
Oh, yeah. Now we're at the stage that everybody figured out that they need to move to clouds and Kubernetes and what's not. And now everybody's screaming kind of, hey, what about security, right? You cannot think about those things before you start doing something, right? You need to get familiar with where you're moving to. And then it makes a lot of sense that security has been now the focus, right? Or one of the focuses.
And on today's show, we've got Stephen Chen on from JFrog. Stephen, how are you doing?
Doing excellent. Thanks very much for having me on.
Do you agree with the statement that I made? That everything supply chain is probably going to be, and let's ignore AI right now because I think AI is still too nascent. We may be talking more about it in the next few years, but let's table that one.
I agree, but I'm going to qualify what I think has been the big change in the past year plus. Obviously, large companies, enterprises have always had security teams, CISOs, folks who are focused on making sure that their networks, their infrastructure, their enterprise systems are all secure. But the big difference is that the hackers, the folks who are attacking systems, have realized that you don't actually need to go in the front door on corporate security. Open source software and developers and central repositories and our whole supply chain of software is highly vulnerable, and it offers wonderful, easy to exploit backdoors into corporate security systems, and it's directly targeting the developer. So developers now have a big target on their back where they are now under direct assault by the hackers who used to just, go in the front door, attack servers, do all sorts of, more obvious exploits. And now they're doing very clever backdoor exploits. And the most famous one is a couple years old now, but the SolarWinds exploit, where they hacked into the SolarWinds CI/CD system, managed to put in some malicious code, which was then signed as certified by them, distributed to all of their customers, and had a huge impact on government businesses, all sorts of folks, and ultimately ended up in government regulations by the Biden administration to have a focus on software bill of materials, software supply chain security, and trying to close these loopholes in our open source ecosystem.
How do you close it in open source ecosystem, right? Because it's not something you control.
As any government entity is wonderful at doing things. Their first reaction was to put out executive orders and to legislate things which you can't. Like you said, you can't just decree that open source software shall be secure. I think where this has put a lot of companies is like the one lever which the government has is their buying power for government contractors, government agencies. And so the first thing they did is they said, well, with bills like HR 7900 and the new NIST guidelines, they said anything which is purchased through a government agency, through our procurement processes, has to comply with these security standards on open source software. You can't be using software which has any software vulnerabilities. You can't be using software which has any known issues. And I think if you've been following any of the security databases or security exploits, that's just impossible to do. There's a new security exploit every day, every hour coming out, and getting to zero vulnerabilities is infeasible. The number and rate at exploits are being discovered means you're constantly patching, upgrading, updating systems to address security exploits, which honestly, again, this is I think that's one of the big issues in software security when you're a developer and you're trying to address it. Over 90% of the vulnerabilities which tools and systems report to you they're just not applicable. So you spend a lot of time chasing software vulnerabilities, which may or may not actually apply to your system, your deployments, your application. And you can always patch and upgrade the library and, quote, address the security vulnerability, but that's entirely unnecessary in a lot of cases and creates a lot of churn in trying to keep up with software vulnerabilities. So I think that this is the new life of developers now. You're not only responsible to develop code and release code, like we were talking about, to Kubernetes and cloud native deployments, but you're also responsible to secure that code and to make sure that you're using libraries which don't have known vulnerabilities, or at least can't be exploited through the known vulnerabilities. And you have a great tool chain to do quick updates, because if there are issues or vulnerabilities, kind of like the Log4j exploit, which hit us all over the head at the beginning of last year, there's so many systems out there written in Java that use Log4j. They all needed to be updated in a very short amount of time. Otherwise, they were exposed to the security exploit, you would think. Now, the reality was, if you were just using Log4j core, you actually weren't exposed. It was in the dependent libraries. So a lot of systems people updated to the latest version to address the security vulnerability when actually their systems weren't exposed to it. So I think that part of the game now is not only security is now the job of developers, but it's getting smarter about identifying and isolating which vulnerabilities actually apply and are targeting our systems or even our machines.
So that means that we are in a way moving away from, if I'm understanding right? We are moving away from static analysis, you have 5,735 vulnerabilities into some kind of runtime analysis, this is what is used. Is that the direction we're going to? Because Log4j vulnerability really matters only if I'm using, or some process is using Log4j, right? For all I know, every single application written in Java has Log4j, no matter whether it's using it or no, because it's dependency of some library for sure, right?
Yeah. And the Log4j case, it was specifically related to like JNDI execution. So you also had a flag properties you could use to turn that off if you were smart as well. So I think the key is it's contextual analysis of the vulnerabilities. So either static or dynamic analysis of your application to figure out, is your application, the way you use libraries, the way you're using the code, actually exposing you to vulnerabilities in production? Now there's another aspect as well to security, which matters a lot for developers, which is we've been talking about security vulnerabilities which affect your runtime library and executable code. The new attacks, in particular ones which are targeting central repositories like NPM, PyPI, Maven Central, etc. What they do is they find different ways to get developers to use malicious libraries. Common ones are typo squatting. So we found a case where an attacker group was putting in libraries which were very, very close to the Azure libraries in NPM, just without the prefix. So if you accidentally left off the prefix for any of the Azure core libraries, you'd end up with these like cloned malicious libraries. And they put the malicious code in the packaging script. So you don't even need to call the library or use the library. Just by the fact that you have a dependency, you download it, and the unpackager gets called, then your computer is exploited. And typically what they're looking to do is they're looking to exfiltrate some sort of useful data, like maybe your OAuth tokens for GitHub or some, production secrets or something, which they can actually exploit and use for other purposes. So I think this is particularly challenging. I mean, we all use a variety of different central repositories, like if you're a JavaScript developer using NPM, Python developers using PyPI. And those central repositories are coming under attack because there's very few safeguards in place. You can upload new packages. You can easily put code in there which isn't reviewed or code checked or scanned. There are even cases where attackers are specifically going after expired domains of popular open source projects so that they can then get credentials to push updates to projects which contain malicious libraries or packaging scripts or code, which will get executed on developer machines. So I think this is, again, like it's an easy target. It hits a very wide net of developers and companies and gives well-funded attackers a direct line into the software supply chain to do some serious damage.
But it's also, from what I'm gathering, it's also partly as if developers, some behave almost as if they're not developers. Like, like you could easily trick my mom into using something that only she and 5 other people are using, right? I would have somehow assumed that a developer doesn't just, first result in Google or whatever, or something like that, that you check at least, okay, are there active maintainers of this, right?
You're in your IDE, you're coding, it's code completing for you all the time. Like you just type in part of a word and it's completing the code for you. And then somebody's typo squat, your typo error, the code completion sees it's a valid package. It's like, aha, you meant to type this. And now I'm going to get that package and I'm going to unpackage it and now you're exposed. So it's not just developers being lazy, it's our tooling, it's our infrastructure, and the hackers are very clever about ways of it injecting themselves into that ecosystem and finding the flaws in our systems. And if you think about it, back in the days when, for example, like Maven first came out for the Java ecosystem, the world was a much safer place. The way you put new libraries in Maven Central is you build them and you upload them and they're released. So you're basically trusting the developer's laptop, which built the machine. I mean, now they're probably using, GitHub Actions or something now. You're trusting them to be like a member of the project. They now verify PGP signatures, but like there's a lot of holes in the system where attackers can inject themselves and try to get malicious code published at central repositories. And we did some scans in our security research team of, for example, the whole PyPI index to find examples of libraries which did, for example, code obfuscation, where like a large portion of the library, you simply couldn't read the code, or which would do remote code execution, a whole bunch of things which you might have a valid use for in Python, but probably it's kind of a sign of some malicious behavior, and found like literally thousands of packages which were uploaded and were doing things which were potentially malicious. Either simple things like exfiltrating passwords out of your browser, stealing Discord Nitro tokens. But once attackers have a line in, it's a lot easier to do more malicious things like we talked about, like getting auth tokens, getting enterprise access. And so a well-funded attacker could do quite a lot of damage.
So how do you counter that, right? I'm clear on how do you counter that somebody does something in the middle of my pipeline, whatever the pipeline is doing, right? That somehow I get. But how do I prevent people from putting malicious thing into the code that I'm using as a library and have zero control of or awareness of what's going on there?
Yes, I think this is a good question. This is a very hard problem. And like I think if you look at it kind of as a fundamental, like what open source authors want, like I'm an open source author myself. And all I want for my projects that I run is that I write great code and folks who use my library can easily access it, can get built versions of it, which are secure and easy to use and are safely distributed. And like as a maintainer and author of an open source project, all you want is to get your code and your great work in the hands of others, where they don't have to worry about, is it safe to use? Is it been exploited? Is there like a middle man in the middle attack on a central repository distribution or something? And I think we just haven't given open source authors really great tools to distribute their software safely, modern, secure, validated ways of doing this. And this is one of the goals of the Pyrsia project. So this is a new open source project, which is originally developed by JFrog. We've now donated it to the Continuous Delivery Foundation. So it's an incubating project at the Continuous Delivery Foundation, which is part of the Linux Foundation. The goal of the project, well, kind of the three goals of the project. So one is reliable, always up distribution. So having a very reliable distribution network of open source libraries, and it's just targeted open source only. The second goal of the project is to have a transaction ledger so you can validate the software you get from the network. So that makes it easy when you get a software package to validate that here's the provenance of the artifact, here's information about how it was built, how it was verified, and the author and all that stuff. The last part of it is having secure verified builds of open source software so that you know that the open source software which you're getting wasn't tampered with in the build process. And I think when you put that together, that gives a really safe place for open source authors to distribute their software, because they just add their open source projects to the Pyrsia network. It takes care of the building, the distribution, the verification, all of that stuff. And then the end users know that the software they're getting is exactly that. The base guarantee of Pyrsia is whatever you get from the Pyrsia network is exactly the same as if you built it from source yourself. So if you took the open source author's source code and you compiled it and you built it yourself, you would get exactly the same results from the Pyrsia network. Some additional guarantees around curation of artifacts and ownership by authors and all that. But like the base guarantee, which I think no one else is doing right now, is verifying in a reliable way that it's exactly the same end artifact that you'd get if you built it from source. I think this addresses a big, not the entire, but a large portion of the open source software supply chain problem in a way which supports the open source ecosystem.
So I'm guessing it's some kind of a service, SaaS, right? Because kind of majority of open source projects are not going to run servers themselves and stuff like that.
Yeah, exactly. So the core of the network is a peer-to-peer distribution for open source artifacts. So the members of the project, the Pyrsia project, the member companies run authoritative nodes, which have kind of the full collection of all of the different software artifacts. And then users of Pyrsia, they kind of like BitTorrent, they both get the artifacts off the network and they redistribute just what they download to nearby users. So you're getting the advantage of the high-speed distribution from getting it from multiple sources simultaneously. Similarly, there's a transaction ledger that's signed, and you can also get off the network, which allows you to verify the artifacts and validate information about them and the authenticity of whatever you're downloading. So that allows you to do verification with kind of an immutable transaction ledger, which can't be tampered with. And the last part of it is the build from source infrastructure with verification across multiple nodes. One of the challenges of pretty much any of the central repositories, even ones which have integrated build from source, is that you're relying upon a single source for where you're getting the builds of your open source libraries. As we saw from the very recent CircleCI hack, where they got their infrastructure basically open to attackers for several weeks. So CircleCI's infrastructure not only builds corporate enterprise projects, but a lot of the Linux Foundation projects, other open source projects are all built and run on their infrastructure. And they were exposed to the same sort of potential attacks, which hit SolarWinds by having an attacker in their system with full access to their systems, where any of their builds, any of their infrastructure, and all of their secrets and tokens associated with those builds were all exposed. This is also true of any software being built by a single entity. If you're relying upon a build coming from even GitHub Actions or Circle CI or other build infrastructure, or even a developer's laptop, you're basically opening yourself up to an attack on if their system's compromised, the build you're getting from them can't be trusted. So Pyrsia solves this problem by building the same artifact across multiple different corporate servers, verifying those artifacts against each other to make sure it's exactly the same result. And then the verified artifact is what gets distributed over the Pyrsia network. So it gives you a much higher guarantee than a single company or a single entity who's building and distributing open source software. And I think when you're building software which the entire developer ecosystem of millions of developers relies upon, you have to start with a really secure and solid foundation for that software. If you can't trust your libraries, if you can't trust your operating system, then you can't trust anything which is built on top of it.
So that was mostly from the perspective of maintainers, let's say, owners of a project. Now, if you go back to your example, you said something along the lines, hey, I just type something in Visual Studio Code or whatever I'm using. I have autocomplete. It finishes the code for me and imports the library, right? How do I know that the library I just imported is safe, verified by Perseus or whatever, or not? Kind of. What do I do from the developer perspective? Not the developer of the project, open source, but developer.
The simple answer is we're actually working on a VS Code plugin. So you just
would kind of pop up and say safe, not safe. Something like
exactly.
That, right?
So you can control your local Pyrsia node for integration for downloading Pyrsia artifacts. You can click on any artifact in your build, any dependency, and then if you already got it from a different central repository, you can replace it with a secure version from Pyrsia. And it makes it easy to see which libraries are verified or not verified according to the transaction ledger in Pyrsia. So I think that from a developer standpoint, it only works if it's easy. If it's easy to use, it's intuitive, it integrates with your IDEs and your tooling. The slightly more complicated and longer answer is for each language ecosystem, and we started with Docker, now we're adding Java support. We plan to add JavaScript, Python, Go, Rust, etc. So all the popular languages and ecosystems. For each language ecosystem we're working with, we're doing a very tight, seamless integration with package managers and build tools so that it's pretty transparent from a developer standpoint. So you can just install Pyrsia, configure it for your project or your build, and then it will replace, and rather than you pulling libraries from a potentially vulnerable central repository, you instead pull libraries from the verified Pyrsia network. And it's pretty transparent. You're getting the same open source libraries. They're just independently built and verified, and you can see the certificates, tokens, and authenticity of what you're pulling down.
We're running into a problem of there are two possible options. I can see this being very successful. One is that majority of open source projects adopt it, which would be fantastic, right? Or that some adopt that, some adopt something else, right? Whatever that something else is. Are you thinking of some kind of standardizing API, like what is happening right now in other areas, right? That there is a standard interface that you can use, and then, hey, implementation could be Pyrsia or something else. But I, as a user, am probably not going to install 75 plugins, right? Because different projects are validated in different ways.
Yeah, no, I think this is a good question. And like standardization and having things be vendor neutral and support across the industry are really important. This is the reason why we decided to donate the Pyrsia project to the Continuous Delivery Foundation. Some other organizations which are also supporting Pyrsia are Docker for, Docker and the cloud native ecosystem, Oracle for Java. We also have contributions from Deploy Hub, from FutureWay, and from some other companies which also care a lot about software supply chain and securing open source. And of course are open to more companies joining and helping out in the project. For open source maintainers and folks who develop software, there's actually nothing you as an open source maintainer need to do to have your artifact available on Pyrsia, because it's the people using the Pyrsia network who request the software, who are saying, I want a build of this open source project. And then Pyrsia grabs the source code, does the build, does the verification, returns back a verified artifact. So it's pretty seamless and transparent as an open source author, where your code is available via Pyrsia just by the fact that people want it and are using it. And I think as a developer, this gives you choices. So you can stick with the central repository for your language of choice, which if you're fine with the kind of the security profile and what they're doing and the, performance and reliability, that's fine. If you care a lot about, the security of the packages, you want more information, you want to contribute to like a vendor neutral open source network, then Pyrsia is a great choice. And it also has the advantage of being universal, so you can use it across multiple languages and technologies. And, if other folks want to find better ways to distribute software, that's great as well. But hopefully they join the Pyrsia project and can help to contribute to what we think is a good technological foundation and a vendor neutral, well-governed project for supporting open source supply chain security.
Did I understand right? If I didn't, that sounds awesome. So if I'm importing a library, I wouldn't be importing a binary. I would be importing through Pyrsia, basically. I would be importing a binary, but that was compiled on the fly, right? Into my project through Pyrsia, something like that, right? So I don't get a jar. I go through Pyrsia, which takes the source code, makes sure that everything is fine, and spits out the jar for me. Something like that, right?
Exactly. So the way of thinking about this is you request, in the case of Java, you're requesting a module, and you have a coordinates for it, right? So you have the group ID, the name, and the version, which you want to get off the network. If this already exists and it's been built on the Pyrsia network previously, you'll get that version off the peer-to-peer network. And you can also verify it in the transaction ledger that the version you downloaded is exactly the verified version, which was built previously. If it doesn't exist, then it will get built. Maybe it's a new version or an update or something that's been added recently. And then after it's built and verified, then again, you get it off the Pyrsia network. So I think that this makes it easy for open source maintainers because their libraries, if they're popular, become available on the Pyrsia network. It makes it easy for developers because they also don't need to worry about verification and like security of libraries. And, I think it's the right pattern for how we want to be building and consuming open source software. So take the hands of distribution and verification and building, take that burden off the open source maintainers, and have a dedicated vendor neutral network which does all the heavy lifting in the back.
Very cool. You mentioned earlier containers. Does that apply to what's inside containers or container images? What's inside container images or container images itself? Would I somehow through some mechanism get image itself, I don't know, Postgres or whatever I'm using, right? That is following the same process, give or take?
Yeah, so for the Java implementation, which we're working on now, this is the full package in terms of it's the distribution, it's the building and verifying, and the storing in a ledger and giving the authenticity. Docker's more complicated because it's kind of like you have the Docker image, but then there's software that's built into the Docker image, and there's operating systems, which are also base images and things, which are also there. So what we did with that is we worked together with our partner Docker, and we're redistributing the verified Docker images over the Pyrsia network. This is also how we prototyped and got out the peer-to-peer distribution network. So we could make sure we had the scale and speed and reliability for that part of the project. We haven't yet implemented the build from source verification in the Pyrsia network for Docker images, but we plan on doing that. But like you said, the challenge with that is to do it reliably, you also need to build everything which goes into the Docker container from source. So the other work we're doing for Java, for JavaScript, for C and C++, for all the other languages will contribute towards being able to actually fully build and verify Docker images, which to my knowledge, nobody's actually doing in a reliable and fully verified way. And when we get there, I think that's a huge game changer because that allows you to pick up base images, packaged Postgres or other packaged open source projects, and really have a high level of certainty of security around those distributions.
Yeah, that sounds like tremendous work, because it can be from compile Ubuntu as a base image, right?
Exactly.
Oh, Ubuntu not enough, kernel, right? It's almost a never-ending story. But potentially, as an end game, that would be absolutely awesome, because me using containers or public images as containers might easily nullify the benefits I get. I'm safe with the libraries that I import into my code, and then I use this base image, and everybody uses some base image that happens to
Exactly.
pick up.
Yeah. Right? No, it's quite challenging. And if you take any Docker container, put it on the shelf for a month, and scan it with a vulnerability scanner, you go from like potentially something which has no known vulnerabilities if it's super up to date to hundreds of vulnerabilities which have been discovered just in a very short period of time. So pretty much keeping a large install base and Docker image free of vulnerabilities is virtually impossible over a period of time. And I think something else, this is an entirely different topic, but something else which I think is important for the whole open source ecosystem and developers in general to embrace more of is languages and technologies which are memory safe by design. A large portion of the software vulnerabilities which are exploitable in large code bases are a result of missing bounds checks or other memory safety issues which happen in languages like C and C++ and other languages which are not fully memory safe and aren't designed to protect you against that class of programming errors. The tools we write software with need to get better at protecting developers from making errors which allow the code to be compromised or allow there to be software vulnerabilities, a large number or easily exploitable software vulnerabilities. Rust is one of the languages which is designed to be secure and have a memory safe design if you use only the safe libraries and calls. And I think that this is also a way which software developers can protect themselves and their projects from kind of being exploited or to relying upon libraries which have security vulnerabilities in it is moving towards more memory safe languages and away from languages and technologies which expose us to more software vulnerabilities.
In other words, what you're saying is C developers move to Rust.
No, I mean, there's a bunch of other high-level languages which do this as well. So like, Java, for example, applies memory safety because of the virtual machine, but it's not, higher level languages aren't suitable for everything. You have kernel device drivers, you have like software running on the edge devices or like Raspberry Pis or ARM system processors. And if those low level libraries are vulnerable, everything on top of them is vulnerable as well. So think of your average router running some sort of like ARM-based Linux operating system. That's the first entry point into everybody's house, and it's probably one of the biggest known vulnerabilities that hackers love to exploit. How often do you update the firmware on your router? Even if the answer was like yes, religiously every time there's an update pushed, even the best hardware manufacturers update their firmware in the months time frame for new products. For old products, if you're lucky, you'll get an update a few years later for very, very large known security vulnerabilities. So you're not the least bit safe if you're running software on devices which are exposed to the internet, such as your router, which are constantly being exploited because of newly discovered vulnerabilities in non-memory safe languages which run at the core operating system level.
Let me ask this question, and I'm going to get a lot of hate mail for this. Why do we still need open source if we're having this much trouble securing it?
So that's a great question. And I remember, I'm kind of dating myself, but I came from the era where it was hard to convince companies to use open source, not just because of software vulnerabilities, which we're talking about, but because they didn't trust open source developers and folks developing open source software. They would rather buy it from a vendor or like a closed source proprietary company. And the industry changed around this because if you think about it, if you're putting your business and your code base on a proprietary product, which you can't verify the algorithms, you can't verify anything about the code base, and you also, in the event that the company reliant on goes out of business, you also can't make any updates to that software in the future. That is a much bigger business and security risk to your business than relying upon a open source code base, which has a lot more eyeballs on it, a lot more users, a lot more reported security issues, which are being fixed constantly. I think it's actually the opposite. If you care about security, you would prefer an open source code base because you know that the amount of peer review, vulnerability discovery, and vulnerability fixes going into it is so much higher than any proprietary code base where it can't be reviewed, it can't be audited easily. I mean, of course, you can hire dedicated security auditors. And, in the event the company goes out of business, you also can't get patches, updates, fixes for it either.
Also, I would add that I don't think that there is such a thing as closed source software, not open source at all. I'm yet to find an example today of some proprietary software that doesn't use open source behind. You don't see it, right? But did that vendor really write all the libraries that source code uses? Is it running on proprietary open source system? A proprietary non-open source operating system? Is it compiled with something that is not open source? I don't think that such a thing exists. You just don't see it.
Yeah. So most commercially developed code is 70 to 80% open source software by just, volume of code. So even, like you said, even getting proprietary code, it's probably using open source libraries, open source dependencies as well. Aside from that, probably another big portion of it, at least a good 5 to 10%, is copy pasted from Stack Overflow. and now Copilot. So thanks GitHub. So I think that the idea that proprietary code bases are more secure or better than an open source is practically not true and impossible from a business standpoint for you to rely upon. So this is why we all use open source and rely upon open source software and contribute back to open source software. Most companies who use open source software either contribute in small ways with patches, bug fixes, bug reports, etc., or in large ways by contributing and supporting large open source projects and efforts which align with their business and with their needs as a company.
I wouldn't be surprised if we would do some kind of examination evaluation that we would discover that Log4j was fixed sooner in open source project than closed source projects using open source, including Log4j. I wouldn't be surprised that would be the conclusion.
Yeah, absolutely. And it's easy. You just, somebody submits a PR or you get an automated PR by Dependabot and you check it in and you're done. It's fixed. Whereas a lot of proprietary software, it's months before they can actually update, verify, retest the software. And they hope in that period of time, nobody finds and exploits their vulnerable systems in production.
You would get it the next time it comes the time to do upsell.
Exactly.
So we've talked about Pyrsia, we've talked about a few things, but you're from JFrog. Now, unless you're living under a rock, you may not have heard of JFrog. I will give you that. But you've probably heard of Artifactory. You've probably heard of X-Ray. Maybe not as much as Artifactory. But one of my favorite things, and this is silly, but it's a big deal to me, is the JFrog CLI. One tool that connects to all the different products. Genius.
You're giving a very if Ayal Ben Moshe, who runs the community team, heard that, he would give you a big hug right now, because he does all of the plugins for like Jenkins, Circle CI, for all the different source control systems, and also his team builds the CLI and some of our new security scanning integrations. And they're all about community, all about like making things which are easy to use for developers, and which so he'd give you a big hug right now.
Well, I'll receive it in proxy, so I appreciate that. But let's talk about JFrog, the company, right? Let's step, so the JFrog CLI can be used with either the open source projects or the products. And right now, the products are becoming sort of bigger and bigger, especially in the security space.
Yeah, I think as you mentioned, we're really, really well known for package management. Artifactory was the way in which I was managing dependencies a decade ago, and was very, very happy with the product and the experience. I think that we've kind of added to the portfolio with a very, very strong focus on security, and it's on kind of two different aspects. One is a lot of the examples I was giving for supply chain security attacks, for like central repository issues, and also for different security exploits actually came directly from our security research team. So we probably have the best security research team in the industry, with folks who are basically military trained hackers who now do good and work for us and find security vulnerabilities and exploits, but also ways to defend against them. And the other thing, which you mentioned, X-Ray, which is our security product. So we've also been making that best in class, where now it doesn't just scan your dependent libraries, it scans your infrastructure as code, your Terraform scripts, it scans your Docker images, and it also gives you applicability analysis. So rather than just reporting results and making you deal with whether this is applicable to my application, to my use case, it will actually see if the APIs and the libraries and the vulnerable code is executed, and will tell you this CVE is applicable, like you should patch it because you're calling the API, or it's entirely non-applicable, like for your application, for your use case, you can kind of ignore this. Here's why. Because this is the API, this is the library which it's in, and none of your other code in that Docker container calls that. So I think that's really powerful, and it simplifies security for developers, where you're not simply doing a bunch of grunt work, going through and throwing away 90% of the scan results because it's inapplicable. You're letting tools and our security research team's findings, but also our security scanning product do the hard work for you.
But can you convince people that's like, hey, we got these 90 CVEs here, but trust us, our code really isn't affected by any of these?
I think that for folks who have the job of going through and looking through CVEs and figuring out, like, do I need to patch this? This is an expectation that most of the CVEs in the list, which they get back from, let's say you're doing like Iron Bank certification of your product, or you're trying to meet the new NIST HR 7900 guidelines. So the government will give you back a scan result, similar to what we scan in our product. It's going to catch the same sort of vulnerabilities that we do. Your job is to go through and to report on why 9 out of 10 of those don't matter and aren't a security issue, and then fix the 1 out of 10. And so wouldn't you rather have a tool do that for you rather than do it manually?
Every day of the week. So all of Stephen's contact information is going to be down in the show notes. But Stephen, if people wanted to reach out to you, what's the best way to do that?
Yeah, so you can find me on Twitter, Steve on Java. Also now Mastodon, steveonjava.social. I love to hear from people, kind of, see what folks are doing with latest DevOps practices, cutting edge research. You can also usually find me at all the big tech conferences. So I'll be at KubeCon, at a bunch of the tech conferences in the US and Europe as well. Going to be speaking at JFocus upcoming. So excited to meet folks, chat with them, and find out what sort of cool stuff they're working on.
Yeah, and if you're catching this right around the time it releases, which the release date was April 12th, next week you might be able to see Stephen at KubeCon EU. Or, probably more importantly, I will say more importantly, CDCon, I believe, is in Vancouver, British Columbia this year?
Yep, Vancouver in early May.
Early May.
Is that at the same time as OpenCon, right? Open Source Summit, or no?
Yeah, so it's co-located with Open Source Summit, but it's happening Monday, Tuesday, where Open Source Summit starts Wednesday through Friday.
Nice.
Stephen, thanks for being with us today.
Cool. No, my pleasure, and thanks very much for having me on the show.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.